Correlations are perhaps the most basic type of structure that might be present in a database. In my ITA talk, I'll consider the question of how quickly one can find correlations. Maybe the simplest setting in which one can consider this problem of finding correlations is the following. Suppose we have n fair coins, they're all independent, with the exception of a single pair of coins whose outcomes are correlated. So if one of them flips ahead, the probability that the other one flips ahead is slightly increased. Suppose every time we push a button, all the coins are flipped and we get a nice row of data. So maybe we can push the button again, get another row of data. And in general, suppose we're given as much data as we want. This is not an information theoretic question. Trivially, if the true correlation is constant, we only need on the order of log n rows of data. We're asking computationally how quickly can we process the data and identify the true correlated pair. The trivial brute force search algorithm, well, it'll just consider each of the n choose 2 pairs of coins and look at the empirical correlation between them. So this will take time on the order of n squared with a log n or polylog n term. Can one do better? Yes. Locality-sensitive hashing improves on this, and in general the runtime is n to some power that depends on the correlation. If the correlation is quite large, if it's for example a half, then the algorithm runs quite quickly. If the correlation is 0.1 or 0.01, then the algorithm essentially runs in quadratic time. In my talk, I'll describe a properly subquadratic time algorithm, which finds a correlated pair in time on the order of n to the 1.6 and works for any constant correlation. I'll also describe how one can extend the ideas of this algorithm to yield faster algorithms for several other problems, including how one can find the closest pair of points from among a given set, the problem of learning parity with noise, and some related learning problems. My talk will be sometime on Thursday, and I would be delighted if you came. Thanks.